Hello, everybody, and welcome to part 8 of Module 5, which is Cognition. Today we're going to be talking about is the dynamics of intelligence, which is basically kind of referring to the differences in intelligence, so high intelligence, low intelligence, and kind of everywhere in between. So what we're going to start off with talking about is a little bit about aging. So one of the questions that we might have is, does our intelligence change over time, or does it stay consistent? Now, the way that we measure intelligence in psychology, we would say that over time, intelligence actually remains relatively stable. It basically stays pretty much the same. Obviously, this is excluding anybody that has some sort of like catastrophic injury or an illness or something like that that would, cause an issue. But as long as you live, a regularly normal, semi-healthy life, your intelligence will stay relatively stable over time. Now, this doesn't mean that it doesn't change, though. And really what we see is not a gain or a loss in intelligence generally, but a little bit of a difference in how we are intelligent. So there's basically two kinds of intelligence that we talk about in psychology. We have crystallized intelligence and fluid intelligence. And I believe we talked about this a little tiny bit in the memory unit and in the biology unit, and then we'll also talk about it again when we get to development. But basically, we have these two forms of intelligence. Now, fluid intelligence is basically our ability to learn new things, to make quick decisions, to solve problems that are novel, and to use like abstract thought to do things. Crystallized intelligence is kind of the opposite, where it's less about our ability to do something new, but our ability to pull up information from the past. So we're able to use more prior learning. We're able to remember more facts, right? That would all be crystallized intelligence. These like things that don't change over time. Now, what we actually see is that over time, the way we are intelligent changes. So young people tend to have more fluid intelligence, where they're better at solving new problems, better at dealing with issues that they've never dealt with before, where older people have more crystallized intelligence. So we see this different dynamic. And I think the example I've used before, but the one I'll use again is where if you've ever helped out a parent or a grandparent especially, you probably have to like help your grandparents, like your grandma, get on email. Like she can't even get to her email, or she doesn't know how to work the computer at all. But you can just kind of grab any electronic, even if it's one you haven't used before, you can mess with it for a while and you can figure out how it works. That would be an example of fluid intelligence, right? Where your fluid intelligence is higher than theirs. Now, on the flip side, that same grandma that doesn't know how to get to her email can probably remember 100 different recipes off the top of her head without ever even looking at them, right? In fact, she may have never even written down a recipe in her whole life. That would be more of an example of crystallized intelligence. It's things that they've learned before, and it's information that doesn't necessarily change, right? It's kind of like frozen in there. So over our life, our fluid intelligence seems to decrease, and our crystallized intelligence will increase. There we go. So you might ask, okay, well, how do we know that intelligence remains relatively stable? There's actually been some studies that have looked at it. And this one, I believe, is from one of the kind of original studies where it was carried out in, I believe, I want to say Ireland or Scotland or somewhere in that vicinity. But basically, they had done IQ tests on a bunch of 11-year-old kids. I don't remember if it was for school or for whatever reason, they'd had done a bunch of IQ tests. And what they decided was 70 years later, they said, what if we go and we find those same kids and we give them another IQ test and we see, has it changed? And these are basically the results of that. So I think kind of blocked it off a little bit there. But if you kind of just compare the graph here, you can look at the 80-year-old side and the 11-year-old side here at the bottom. Again, that's going to cover that up. But basically what you see is if you kind of connect them, generally speaking, it's pretty much a straight line right here, right? Which would be a 1-to-1 correlation, which basically means, as your intelligence went up when you were 11, your intelligence also tends to remain the same at 80. Now, there's a little bit of a drop, right? And there's obviously a million different reasons for why this is, but overall, it's pretty much the same. It hasn't changed a lot. There's only a very few amount of people who scored really high and then scored really low. And that takes us to kind of some of our principles of test construction. Now, this gets back to assessing intelligence that we talked about before, but one of the things that's really important is what's called a normal curve or a bell curve. We've already talked about these, and we talked about standard deviations in the very first module, the very first unit, when we were talking about using statistics and how those different pieces work. But and the IQ is basically one of the different characteristics that will always fall on a bell curve. So basically what that means is if we went out and we tested every single person in the United States or every single person in the world with an IQ test, they would fall in this shape of a curve, where the vast majority of people, 68%, would fall right here in the middle. Then we'd have smaller chunks on each side of about 14%, and an even smaller chunk of 2 and 1. Again, these percentages are all just standard deviations. As you go out 1 standard deviation, 2 standard deviations, 3 standard deviations, you're getting further and further away from the average score, the standard score. Now, you might notice that on an IQ score, 100 is exactly average. So that's perfectly in the middle. That's right in the center of where everybody is. And if you think back to when we talked about this idea of mental age versus biological age, you can think about that 100 as being this. If you have the same exact mental age as physical age, it becomes 1. When you multiply 1 times 100, you get 100, and that's that IQ score. Now, you can basically kind of see how anybody between 85 and 115 is considered average. That's average intelligence. Once we go above or below that, now we're talking about people who are above average or below average, and then we can kind of see different distances in how far or how extreme that is. If you're above 130, that's a very small group of people, right? Slightly more than 2% of the population would be that intelligent. If you're below 70, right, that's where we're starting to see cognitive disabilities, people that have mental problems would be under this 2%. Again, a very, very small proportion. And then obviously there's the extremes on each end of even further. One other thing that's important to talk about is what is called the Flynn effect. So the Flynn effect is basically this idea that as we've done intelligence tests over time, we've noticed that scores tend to increase over time. Now, that doesn't mean that an individual person's score is getting better every time. What it means is that over generations, we're scoring higher and higher and higher. So basically, kind of, if you can think about it this way, is that if you took an intelligence test and your parents took the exact same intelligence test, you would probably score higher. If your grandparents took that exact same intelligence test, they would score lower than your parents. If their grandparents, so your great-great-grandparents took the same intelligence test, they would score lower than their grandparents, right? Every generation, we're kind of slowly moving, we're moving upwards. We're scoring better and better. Now, again, that still wouldn't mean that your IQ would actually be higher. So the way that IQ scores work is they work kind of like the AP test or the ACT test, where it's on a curve, so it shifts. So basically, over time, that score that you have to get 100 gets higher. The raw score, right, moves up and up and up. But over generations, we are basically getting more and more intelligent. And we'll talk a little bit about why this is. In general, we can probably assume that it has to do with our environment. That we haven't really evolved that much in 100 years. We haven't really changed that much biologically at all. But over those 100 years, we've got a lot better at teaching. We've got a lot better at learning. There's more technology and kind of all these other things that then are pushing those intelligence scores upwards. So let's talk about kind of the extremes. And we'll start off on the low end, the extremes of the low end. So you would be labeled as someone with an intellectual disability if you had an intelligence score test or an IQ test below 70. What intellectual disability is exactly what it sounds like. It's a condition of limited mental ability. So your cognitive skills are just below, or low enough, I should say, to the point where it's going to cause problems in your life for the most part. One of the big things that we see is that there's a lot of difficulty in adapting to life. So someone with an intellectual disability is, generally speaking, going to need some sort of supports in their life. Now, depending on how extreme that is, they might need someone who literally cares for them 24/7. They might not be able to do anything on their own. It might also be, depending on, again, where that kind of number falls, where how high or low they are, they might just need to have a very structured life, right? Where they live at the same place their entire life, they're around the same people their entire life, they'll have the same job for their entire life, right? They might go to the same places every single day, but it's a very structured thing that they always follow because we can kind of practice those basics. And you can see that if you've ever been in a special needs classroom, especially one that works on like home skills, a lot of what they're learning, because they go to school just like everybody else, obviously, but they're not necessarily sitting in algebra class because that's not necessarily as important. They might be focusing more on, okay, how do I keep my room clean and manageable? How do I cook for myself? How do I dress myself? How do I make sure that if I'm sick, I get taken care of, right? All these things that are just kind of more about the fundamentals or the regular demands of life would be something that would be focused on there. One example of a way that we can have an intellectual disability would be Down syndrome. So Down syndrome has a really big kind of like spectrum of where you can be. It can be mild or it can be very severe. So someone with mild Down syndrome can live pretty much a really regular life, depending on kind of what their other symptoms are. Someone with severe Down syndrome, right, with a severe intellectual disability, literally needs to be cared for 24/7 and isn't able to really do anything on their own, down to maybe even like feeding themselves, depending on how severe. Now, the cause of Down syndrome is actually kind of interesting. It's basically where during the formation of cells, literally before childbirth, right, before we're even an embryo, but when we're just a little egg and then we're splitting into a bunch of different cells, basically what happens is there's an extra copy of chromosome 21. So a specific chromosome gets copied an extra time. And basically what that does is it messes with how we are built, right? Because those are our instructions, our genetic instructions for our bodies and our minds and everything in it. And so basically that extra copy causes all of these different symptoms that we see in Down syndrome. And then obviously there's a ton of other things that can cause intellectual disabilities. A really simple one can just be damage, right? If you're in a car accident and you have severe damage to your brain, that can obviously cause an intellectual disability as well. On the other end, we have what is usually referred to as intellectually gifted. Now, there's other terms that people could maybe use, but I think this is probably the one that's most common or most likely to be used. Now, again, this is referring to basically the other side of that curve, right? It's always talking about 2% or slightly more. So this is the top 2% of individuals. Generally, this will be described as someone with an IQ score of 135 or above. And then what we'll usually see, as you can kind of imagine, is just people with intellectual abilities that are beyond the average. So if we're talking about children specifically, right, someone who is gifted is going to be able to learn much quicker than their individuals or their peers. They often are much more likely to work independent as well. We'll kind of see some social things that could cause that. But these are kids who will like skip grades, maybe where maybe they're in 5th grade, but they're able to read at a high school level, and they're just kind of beyond other students. And when you give them something new, they're able to pick it up really quickly. We also have what is called Savant Syndrome. I've mentioned it a little bit before, and we're going to look at some examples of different types of savants in some of these videos. Now, not everybody in here is technically a savant. We'll kind of talk about what exactly defines it and where that kind of cutoff is. But Savant Syndrome is basically where it's a condition, actually, where someone who has limited mental ability has one exceptional skill in a very specific area. So like I said, we're going to look at some of these videos that have a bunch of different examples. Some of the examples are not actually going to be savants because they might be at a normal mental ability, even though they have one exceptional skill, where a savant technically is someone who has limited mental abilities. So we'll see one example. I think I've mentioned him before, but he basically is unable to like truly care for himself. He needs to have someone assist him to live. But at the same time, he is able to memorize basically everything that he has ever read. and he never forgets any of it. So that's an example of savant, right? He has limited ability in most areas, but in this one thing, he has this exceptional skill. And we'll look at some examples of that in class tomorrow. All right, so if you would take a few moments and please do a quick summary on this section, and then you can jump into the next one. Have a good one.